Hi everyone. So in this video we would see how to add all the element of an array using CUDA C program. Okay. So before I explain you how the parallel programming will occur, let me give you some abstract understanding ki how we'll write the code. Okay. So this is how I generally visualize when I write a program in CUDA. So basically, let's imagine you have a host, let's say your laptop or your desktop, like mainly your CPU, okay, which will name as our host memory, host, okay. Then we have a device which is like basically which is GPU. I'm naming it as GPU. So this is how I generally practice writing CUDA program. That will first initialize a variable in our host. Let's say for like we'll declare our array or we'll declare our result. Okay, then we'll also allocate a memory for our device using CUDA malloc. Okay, then we'll simply copy this value from our host to our device. Okay, then we'll launch a kernel function where we'll initialize key how many threads do I want to run those key though to kind of like run those program into concurrently. It means let's say if I have a array of 10 element, sorry, let's say if I have a array of 10 element, right? So I would want key I initialize 10 threads so that each of the thread will work for each of these arrays so that my total time comes to around log 2 of n. Okay, so we'll initialize that also with this kernel function and we'll launch it. And then what will happen in device, the whole program will process and it will get an answer. Then again it will give back to this answer to my host, and from there I will simply print this. Okay, so this is like the basic abstraction how the CUDA program would work in this case. And the question we have is simple. We have an element, let's say 1 2 3 4 5 6 7 8 9 3 3 6 7 8 9 10. We have to add this up. Okay, so normally in a sequential programming it would take big of n, like in normally if you try to solve this using a sequential algorithm, but we'll try to finish that with log 2 base n. Okay, how do you do that? We'll use it's called parallel reduction. And what this means, it simply means key when you halve the size of the problem by combining the array elements. Okay, so let me give you some example how would you do that. Let's say 1 2 3 4 5 6 7 those are there. Okay, now we'll initialize a threads id, because as I said earlier you will initialize 10 threads. So for the first thread the id would be tid of 0, right? Then we'll have another parameter called stride. If you have studied convolution neural network in deep learning, then you'd see that there is a parameter called stride, mean the shift of an element. Okay, so in this case we'll initialize the stride with 1. Okay, and then simply we'll use a multiple with 2, mean in each iteration my stride will get multiple of 2, right? So now let's see the exact execution. So 1 2 3 4 5 6 7 8 9 10. So as I said, I have thread id of 0. Okay. okay, thread ID of 0 and stride of 1 and a multiple factor of 2. Okay, now stride 1 means it will move like this. Okay, and we'll also have a condition that if t of id get modulo by 2 into our stride, and if that is equals to 0, then in our shared memory, let's say partial memory, we'll add the value of that thread id plus the stride. Again, what this mean? This mean is for our first iteration, let's say this is our 0 index, like 0 1 2 3 4 5, right? So for first the shift is like this. So after the first iteration, it will look like we'll add up these two number 3 and we'll put the value into the first one, because if you see 0 modulo with 2 into 1 gives us 0. Okay, so after the first iteration we'll have 3 blank, because 0 1 2 3 5 6 7 8 9, these are the index. Okay, now see 2 and 1 get summed up, we get 3, and we stored that into the first one, mean by like where we get the value of 0 after modulo with 2 into stride. Then again we summed up this 3 plus 4 and we stored the value into 2. 7 again blank, then 11, then blank, then we have, it's how much is this? So 11, we have 15, right? This one, so 15, then we have blank, then we have 19, and then we have begin blank, right? So this is for stride 1. Then we have stride 2. Here we'll sum this. Okay, so we have 10 3, again we have 26 1 2 3, we have 19 gone. Then we'll have s is equals to 4, mean our stride is now 4, so 1 2 3 4 this. So we'll sum it up like this, say 36 2 3 4 5 6 7, we have then 19. Then we have stride 8, so 1 2 3 4 5 6 7 8, so 55. So 55 stores into 0. Then we'll simply print our, okay, so thread id will print our thread id 0, and after that we'll simply transfer that data from device to our host memory, and we'll print that. Okay, so I hope I'm able to give you some basic understanding how that program will work and how generally parallel reduction works. So now let's get into our Colab notebook and let's write the code. So these are the code that we have done in our last video of this CUDA playlist. Okay, so we'll first run this code of NVCC version, and we'll install our NVCC for Jupyter. Okay, wait a minute. Then we'll load our extension for Jupyter, and this was the code that we saw, a simple CUDA program. Okay, and today we'll be doing a program where we need to add all values of an array. Okay, so first we need to mention that it is a CUDA program. Okay, then as it's a C program, so we need to declare stdio.h. then to use our CUDA keywords and function, we need CUDA runtime.h, sure. Then we'll first initialize our main function that will run into our CPU. Okay, return 0. Okay, now, so as I said in the explanation part, that we first need to declare our array and our host variable for the result. So we'll const int n will be 10 because of 10 numbers in our array. Then we'll name it as host array of size of n, 1 2 3 4 5 6 7 8 9. I hope it's all the numbers 1 2 3 4 5 6 7 8 9 and 10. Alright, now we need another variable called age result and we need to initialize it to 0. Okay, now it's time to allocate memory for our device. So int pointer d array and int d result. Okay, now we simply need to allocate the memory. So CUDA malloc, we have void of double pointer, need to pass address of our array, then we need to pass the size of the array. So size of the integer will be 10. Then if I just copy this and run that, and again I need to change this name because this will be result, and here there is only one variable, so it will be size of int, and that's it, right? Okay, now I need to copy this value from host to device, right? So for that we have CUDA name cpy, where I need to pass the parameters. So array, then h array, mean from h array to d array. Also we need to pass the size, so n multiply with size of the in. Then we need to give the direction, so the direction will be CUDA name cpy host to device. Okay, simply. Then what we said, we need to launch our kernel variable. I think there is an error. Is it? No. It closes here. Then we have to size. Okay, let's give some spaces. Okay, ampersand void. Yeah, I think it's all right. Okay, now we need to launch our kernel with 10 threads. Okay, so we'll name it as some kernel. Okay, some kernel, and this is how we launch your kernel. Here I need to give key. We need 10 threads in particular block, so 1 and n. Then we'll simply pass our variable, so d array host array, the number of element. Okay, now it's time to code the kernel function. For this we need to write our global keyword, global, from there void some kernel. The arguments are int array, then int result, then int n. Okay, then we'll simply declare our shared variable as we share in our explanation, it will be much easier for us to work with in place of a global variable. So partial sum, because for 10 element I'm taking it as 10. Okay, now we need our thread ID. So thread ID, and each of the thread ID we need to initialize that. So let me initialize in here. So thread idx dot x will be idx dot x. Okay, then partial sum tid, to give a condition. If tid is within the index of our array, then we need to put the array index to our partial sum, otherwise we'll name it 0. Then we need to sync it so that all the threads first done their work and then it goes to the next steps. Okay, because deadlock is one of the most important thing in concurrent programming. So it will be sync threads. Yeah, okay. Now we need to perform our parallel reduction. So for that we have our we need to declare our stride. So stride would be 1, then stride we need to up to block dim dot x. Then at the straight the increment factor will be multiple of 2. Exactly. Now the condition tid gotta be modulo with 2 into stride, and that have to be 0. And then partial sum, I need to increase that with partial sum with tid plus stride. Okay, done. We'll sync it so that all threads does their work, and then to check with the final value will be stored in our first thread index, which is 0. So tid, if it's 0, then in result we will store that shall sum 0. Alright, so it's done. Then after the calculation in our GPU, we again need to copy that value from GPU to our host, mean our CPU. So here we just need to change the direction. In this case we'll do from, okay, it's saying to run me. Let's run this cell. Okay, so we need to change the direction, right? So in this case, device to host. So from now it's actually we need to pass the result, not the array. So we need to pass the address to the variables. I feel now it's alright or not. It will give me the address of the result. So for D array, it's only D array. It will be D result, and I need that into my H result. Okay. Now I will simply need to print this. So sum of array elements is percentage %d, new line. I'll simply use h result, and most importantly I need to free the memory. The array as well as the result, right? And that's it. Let me run this program. Let's see what it gives us. Okay, there is some error. Wow, mistake. Partial sum, sharing partial sums. I think now it's okay. Sync threads. Yeah, I'm literally sleepy right now. So yeah, so it's giving me sum of array element is 55. So yeah, this was that for this video, and thanks for watching.